Good morning, Michaela. Thank you for working on that worksheet. I am going to be sharing my screen, and as you see here, if I move this out of the way, because I don't know exactly how it shows up. Maybe you see that banner on there. I don't know. I am going to have this open, and I am going to work through this worksheet with you. I'm pretty sure you said you had it done, so that's good. And we're going to work through this worksheet, seeing what our answers should be. I have a split screen with Desmos because once again, you want to look at this problem. If this problem does not have a denominator, it is not going to be discontinuous. And if it's not discontinuous, then we honestly can just plug in 1 for x. So I think, again, I was looking over your shoulder the other day when you popped in real quick and showed me a couple of things. Oops, there I am saying plug in 1, and because I'm talking, okay, plug 1 in straight across and whatever you get. So this problem right here, your answer should be -2. That is the answer. You are done because, because since it is not discontinuous, that will be your answer, okay? Same thing with this one. It is not discontinuous because there is no denominator. So we're just going to do 3 minus 5. That one might be a little bit easier to do in the head. 3 minus 5 is, again, -2. Do not always think your answer will be -2 just right now. This is the first one. What we probably should do first is plug it into the denominator. So we're going to look at 3 minus 3. First of all, you should know 3 minus 3 is 0. That's okay. If you need to plug it in, cool. Okay. So you're going to plug in 3 minus 3, that's 0. I'm sorry, the board that I'm using is working, but it's a little bit funny. So then we have to plug 3 into the top. If it is not a negative number, don't worry about using parentheses. You can just use times, but you can also use parentheses for this. All right. When we plugged in -6, 3 squared minus 3 times 10 plus 16, we got -5. All right, I'm going to come back to that one in a minute. But when we get a -5 over 0, that's the one where we're unsure of what to do with. So I'm going to come back to that one in just a quick second because I'm going to move on to this one right here, right? Plug in -3, but be careful the denominator is +3. So let's move over here. Let me make sure Desmos will be happy with me. So let's do -3 plus 3. Yep, that is 0. Please be careful with parentheses. -3 squared plus 8 plus 8 times -3. And then we've got plus 15 at the end. So notice on this one, we do get 0 over 0. Okay. When you get 0 over 0, what that means is there is a common factor. Okay, let me move this just a little bit. Apologies for that. I think those will all stay lined up. When you get 0 over 0, you are going to be able to factor that problem and reduce it.
Good morning, faculty. The time is 7:35. As a reminder, we'll be gathering for our meeting this morning.
If we try to factor this,
about 10 minutes in Mr. Dribble's
factors of 15. Sorry about that announcement in the background. Factors of 15 that add to 8. We would do x plus 3, x plus 5. And then we'll do x plus 3 in the bottom because that's what it is. Sometimes it's nice to keep it in parentheses. We're going to cancel those out, which then means this reduces, sorry, my reduce is kind of sloppy there, to finding the limit as x is approaching -3 of x plus 5. Now, it's a little bit different, but would you please look at this problem right here? Do you see how that says limit of x minus 5, right? Limit of x plus 5 here. So all we're going to do is plug in, even though it was originally illegal, we are now going to plug in -3. What is -3 plus 5? So our answer on this one here is 2. Okay. So what do you do if you get -5 over 0? That means we're going to get something a little bit weird. So since we're going to get something a little bit weird, what we're going to do is plug in a number that is close to 3. Okay, we're going to plug in a number that is close to 3. All we care about is whether it is positive or negative. Sorry for all the extra noises. Okay, so a number that is close to 3 is 3.1 and 2.9. Okay, because again, if we think about that, you know, right when we were on the graph originally, 3.1 and 2.9, it doesn't matter, you could have said 2.9 and 3.1, but what I'm going to do is plug that into both of them. Okay, so I'm going to do 3.1 squared, which is something we don't know maybe that easily, minus 10 times 3.1 plus 16. Okay, and then in the denominator, we're going to do 3.1 minus 3. Here's the funny thing, Michaela. We don't really care what the crazy decimal says. We care whether or not this number, this was the numerator, remember I plugged in, is the numerator, is this 5.39 number positive or negative? Okay, so that's going to be a negative. This number down here, is it a positive or a negative? So we're going to have a negative divided by a negative, excuse me, a negative divided by a positive, which means this side, when I plugged in on this side, it would be negative, and it's actually going to be that negative infinity. Because again, anytime you get a number over 0, your answer is going to be infinity. So when I plugged in 3.1, I got a negative infinity. Okay, let me go back to Desmos here, and I'm going to plug in instead 2.9. So let me just change all of these to 2.9. 2.9. This one right here, 2.9. Okay, funny thing, you should never be surprised that the numerator really isn't going to change signs. Because if I'm close to 3, my answer probably should be close to -5, meaning most of the times when I plug in the numerator, if it is originally negative, your numerator over here is going to be negative, but it's never a bad thing to plug it in. Look at the denominator, 2.9 minus 3 is negative. A negative divided by a negative would equal a positive. Now, you don't necessarily have to write the positive there, but Michaela, once again, in a different video, I talked about this. In order for there to be a limit, if I'm looking at 2 different sides, remember, if I'm looking at 2 different sides, the answer should be the same. Yes, they're both infinity, but are they both positive infinity? Are they both negative infinity, or are they different? Since they are different, that means on this problem, and I'm sorry because I'm split screen, limit does not exist. Okay, and so if you want to continue working your way through, not only because I have had a couple warnings, I'm sure there's going to be a couple other things. I wanted to work through a few of these with you so you could see what to do. There are a few that are a little bit strange on here for factoring and reducing. But now you have answers for 1, 2, 3, and 4. I'm going to clear all this out because looking through the rest of these all are fractions, meaning something weird could go on. You could get a number over 0. 2 I want to talk about. I forget what 2 they are, but I think they came up. Michaela, we can use Desmos to help us out on this as well, though. We had an issue with 5 divided by 0, and this Desmos will even tell us that is undefined, but we shouldn't have an issue with 0 divided by 5, even if that was 0 divided by 53 or 0 divided by 17. 0 divided by a number, your answer will be 0. There is no issues with the limit. The other thing is, please don't forget, sometimes when we get our brains in this limit thing, if you plug in the numerator and get 1 and plug in the denominator and get 3, there is no issue with that. Remember, Desmos can leave your answer as a fraction. If you get 1 over 3, your answer is 1/3. Don't try to plug in and try to find limits with that. If you get 2 numbers out, it's kind of like this up here. When we plugged in number 1, let's see if I can still do it. When we plugged into number 1, my lining is a little bit off, I think, but when we plugged in number 1, we just got -2. Just left it as that answer. So if you plug in and get a fraction, your answer is just going to be that fraction answer. So sorry, short, quick video, but I wanted to go through a few of them to make sure you kind of knew what you were doing was right. Confirm those first 4 are right, please. Confirm that you understand what's going on, and then work on the rest of the worksheet. Thanks.